This morning we have come here to learn. And so we need to open our eyes. We're going to be listening to, but we are coming to educate ourselves. And sometimes people ask me whether I am one of you, and I say no. We are like we are like parallel lines. They never meet. But because I've been sitting here, sometimes I'm able to speak their language some. This is also a bad expression. Don't go and speak it anywhere. Distinguished ladies and gentlemen, today we have an architect as our chairman. An architect speaks, a materials engineer speaks. And they are not, what they are going to be talking about will be broken down to pediatric levels such that we'll all take something home. And so, our chairman is a Kumasi man. I mean, true and true, a Kumasi man. Schooled at KNUST Basic School. Attended KNUST, SHS. That used to be called TechSec. Entered the University of Science and Technology then to read BSc Design. Then he followed up with postgraduate diploma in architecture. Went back to the same KNUST to read Master of Science degree in architecture. And then back to the same KNUST at the UCC in New Legon in New York to read PhD architecture. He has done a lot of work. In fact, some 3-4 months ago, no, I think it was in December. It was in December. I was sitting in soon to be Dr. Oman's car. Where the area that has been redeveloped. No, it's not Dakujum. The in so the Nyame. We saw a very beautiful building. Then Dr. Oman said, Dr. Keke design you. He has worked very extensively across Ghana. Distinguished ladies and gentlemen, a pioneer when it comes to architectural heritage. Ask him anything about the forts and castles and he will give you the history. And some good work done. He is no other person than our RSA president incumbent, architect Dr. Kwejo Tumesi Ampofo is our chairman. Upper life, chairman. Okay, not few as they used to be before I started. Chairman, your audience, our life boring chairman. Another round of applause for him.
Thank you very much. Our scientific secretary, Dr. Isaac Kofi Jansen. For those who don't know his full name, that's his full name, Dr. Isaac Kofi Jansen, our scientific secretary. Thank you very much, Dr. Jansen. I accept to be the chairman for the day, and as we always do it, today is another presentation, and we are going to have 2 of our scientists present for us. And first on the stage to present is a senior research scientist. He is the head of Geoinformatics Division and the coordinator for this space, National Artisan Training Center. He is a specialist, an architect specialized in barrier-free designs. So no matter who you are, even if you are not able to walk, if you can't hear, his designs are accessible to you. He is also a specialist when it comes to the use of local building materials in terms of sustainable architectural design. He has been championing sustainability even before the goals, the UN sustainable goals, those things came up. We've been doing that all these years. He is a pescoba. He schooled at Nkwetia St. Peter's Secondary School for his A level and went through BSc Architecture at UST, postgraduate diploma in architecture also at UST, Master of Science in Architecture, KNUST, and a PhD also at KNUST. He is senior architect, Dr. Joseph J. Dankwa. Please, let's give him a clap as he rises to give us his presentation. We give him 20 minutes and we have 10 minutes for questions and answers. So listen attentively and be ready for any question for him today. Today he is in our court and he is now our witness for today, and any question you bring up, he can't say no. He would have to answer for us to understand his research. Thank you very much. Again, please be reminded that we are live on Facebook. So other colleagues have joined us, and today is a special day. Before he goes on, we see in our midst today our national RSA executives. We have in our midst our national RSA executives. Where is Engineer Shadrach? Oh, okay, all right. So we have our immediate past national president, Engineer Doctor of Agric. Let me be emphatic here. Shadrach Amponsa. He has left to see the director. And again, we have our RSA secretary, vice president, currently the vice president. He is vice secretary. He is in the person of Dr. Engineer Doctor of Agric, Felix Frimpong. I call him the wheat master. He is a history maker. You could never grow wheat in Ghana until his research came up that indeed you can have wheat and harvest it in commercial quantities. Let's give him another round of applause. That is an impactful research. And next to him is our national president, RSA national president. He is a geological engineer and a geophysicist. He is the head of groundwater and geoscience division at CSIR Water Research Institute. He has been in the CSIR for over 16 years, and he is in the person of a senior research scientist, Engineer Dr. Collins Okra. After our presentations, RSA will stay for a while and listen to what our executives have for us. Thank you very much and welcome. Doctor, please go ahead.
Thank you, Chairman. And good morning to all of you. I hope you can hear me. All right. This morning, I want us to share something about relationships. And when we talk about architecture, sometimes we are only thinking about the design or in terms of the art. But today, we'll delve a bit into social science, okay, and the relationship that actually establishes the service that we give to clients. I believe some of you have already received services from an architect or somebody who calls himself an architect. So today, we'll be able to see the kind of relationship that we have across the building production chain and how it affects building quality in our homes or the spaces that we live in. So this morning, it's an ongoing research. We are yet to finish, so I will share the progress as and when we have reached and then the way forward. So the topic is Beyond the Blueprint, Client-Architect Relationship Dynamics and their effect on architectural service delivery in Ghana. We believe that building shapes our lives and also affects the quality of life that we have along our product life cycle and then our lifestyle. So we believe that whatever it is that we do definitely the architect is very important. But most often we perceive architects in a different way in terms of service delivery. So this morning I would like to enlighten us about what the architect really does when it comes to a good quality house and how our services affect in terms of the relationship that we deal with one another across the value chain. But what has been the problem? We see that there's a lot of building construction that is ongoing in our urban centers. But then we also see and hear from the news that there's always the problem of quality when it comes to buildings. Some collapses, others causes indirectly ill health and etc. And much of the time, the blame is put on the architect and other professionals. But then, is that really the case? Or there is a problem with the relationship that we have with our clients? And we believe that the client-architect relationship, that's from the trust to contract structure, communication, and power dynamics, are the real primary variables that actually affect quality of work. But yet, if you look at literature, there's little that you can find when you look at how relationships affect quality of buildings across the value chain. So the question then arises as to how do architects in Ghana describe the typical client-architect relationship and what conditions affect the delivery of architectural quality services. Again, I'm asking that at what stages does the client-architect relationship often deteriorate and the consequences for building quality outcomes? And then thirdly, how do clients understand and value the architect's role, and what does the gap between the client perception and the professional quality or professional reality reveal about information asymmetry? Now from this, I have these three objectives. And the first one is to examine how patterns of engagement, contractual formality, trust, communication, fee structure affect the client-architect relationship, either enabling it or constraining the quality service delivery across Ghana. Again, I want to identify the stages at which the client-architect relationship commonly deteriorates and evaluate the consequences of this breakdown when it comes to contract service delivery in Ghana. And then thirdly, to measure the gap between client perception and architect's understanding of its professional rules and determine whether this independently predicts poor service delivery outcomes. There are some key terms and theories for which affected my study in terms of literature. And the first one is self-qual. Now, this is a portmanteau, an acronym for the word service quality. And it stands for an assessment model that actually assesses a quality of service, which assesses the gap between the perceived, that's the expectation of the client, and then the perceived delivery. You know, for every client, they always have an expectation when they are engaging their client. In this aspect, I'm dealing directly with the architect. And so how does the client expect the delivery or the service that you are giving to him? And then afterwards, what is it that he's really looking at? So you see that there's always a gap. And that gap is the measurement of that quality that they call the service quality. And this is hinged on 5 quality dimensions. The first one is tangibles. This one, we are looking at the drawings, report, and then the office presence. Reliability, responsiveness, that is how prompt you are to seek answers to the professional whom you need that kind of service. And then we have assurance and then empathy. Assurance is the knowledge. How deep do you know the needs of the client? And how are you able to communicate and align with his needs such that he will have that kind of satisfaction? And this is where the empathy comes in. And the second theory or the key term is the transaction cost economics. It's not transact, it's transaction cost economics. And this one talks about a theory that argues that for every price, it is not only the surface price, but it is the full cost price, which involves the whole process, that's the value chain. And so it involves the hidden cost for which the client often do not see. So there is a perceived cost, which is often higher, and this has got to do with the architect's fees, the ongoing supervision, contract negotiations, project delays due to processes, and then documentation process. But then there is this also, which is the perceived benefit that is undervalued and for which the client always relegate to the background in terms of the output, the design quality, okay, which is invincible until there is defect. The site supervision, which the benefit is unclear to the client, or he doesn't really understand it. There are dispute prevention and abstract, for which the client is also not averse to. And therefore, he seems that everything will be okay. There's compliance assurance assumed, and there's a long-term building quality. Now, client often bypasses this engagement, which now he self-manages the project, and therefore will lead to truncated architectural services and also affect the quality of the service for which the client needs. Now, the third key term is principal-agent theory. Now, this is whereby we have a principal and then we have an agent. Now, the principal is the client in this case. So we have the principal, who is the client, who delegates a task to the agent, in this aspect, the architect. Now, in this way, there's a delegation, but there's also an output. And so the client owns the project. He pays the fees, but cannot assess the work in terms of his knowledge. And therefore, he cannot perceive and assess how well the design has been made or how well the supervision has been conducted. At the other end, who is the agent? The architect. But he is also the one who delivers the service, holds expertise, and then sets effort levels. And so this is how the back and forth between the principal and then the agent happens. But because there is an information lack, the client does not really understand the full services of the architect, and therefore it also arises in frictions and problems. And three structural problems that we see, which literature has stated, is that we have information asymmetry, we have misaligned incentives, and then we have incomplete contracts. And this as a result of the gap which results between the principal and then the agent. And then the last one, which is the fourth key term, is information asymmetry. Now, for the information asymmetry, it is said that the client and then the architect, they have information, but then the information is not balanced. For the client has only 10% of the information, and that is what is visible to him, and so that is what he sees, the drawings, the planning permit, and then the pretty images in terms of the 3D designs that you give to that person. So for him, this is what he perceives as the service of the architect. But then there are the hidden deliverables for which the client does not know, and for which actually brings out the product, which is the 10%. That results in the drawings, the planning permit, and then the pretty images. But then the hidden below, that's the 90%, are what you see. The structure calculations, the design specifications and compliance to the building code, the research that the architect will go through, material quality checks and etc., negotiations, certification of works and etc. Now, these are things that are done at the background for which the client does not know. But yet, there is that kind of information imbalance for which affect quality services. And so the paradox is that the client lacks the expertise to evaluate architectural services. And so because of that, they cannot see the value of the post-contract supervision, and therefore they eliminate and reduce the architect's supervisory role, thereby eliminating the oversight, which exactly protects their investment. So because of their misunderstanding, they actually take certain actions that actually result in the poor quality service that they have. Now, so this has become the hypothesis, and this has become the assumption that the quality of the client-architect relationship has a statistically significant and positive effect on the overall quality of architectural service delivery. That's both post-contract and pre-contract and post-contract in the Ghana's construction industry. So this is my assumption for which I'm perceiving the study. But then it will come otherwise when the decision has been made and then analysis have been done. That is when you'll be able to know whether the hypothesis is true or false. Now, in terms of literature, there are 6 thematic clusters for which I delved into in relation to this topic. And the first one is the architect's role and scope in terms of what is it that the architect does right from the time of engagement to the time that he's disengaged or he closes the work. I also looked at the Ghana regulatory framework in terms of the policies and guidelines that direct the practice of the architect. I also looked at the architect-client relationship in terms of trust and power dynamics, communication, and etc. And the fourth one is the building quality in Ghana. What does publications or the literature say when it comes to building quality in Ghana? And then contractual frameworks, informal versus formal. We all know that in Ghana here, forms of contract are different. Some are even verbal, others are written in that aspect. So I looked at that, I looked at procurement, and then the transaction cost economics in that aspect. And lastly, I looked at theory and then the research gap that this research is trying to fill in terms of utilizing the theories and the key terms for which I have already elaborated. For the first one, which is the architect's role and the scope of services. For those of us who do not know, but the architect, right from engagement, that's from inception and briefing, throughout the entire project lifecycle course to handover and close out. These are the stages. These are the 6 stages for which the architect is required to go through and for you to ensure that you have quality building product. So from stage 1 up to stage 6, for the first 4 stages is the pre-contract. That is what we call the pre-contract. And then from stage 5 and 6 is what we call the post-contract. But what we have found out is that for the post-contract, that is where most of the clients disengage the architect because he feels that he has gotten what he wants. And therefore, he gives the rest or he entrusts his investment to either the foreman or the mason to continue doing the work. Now, when it comes to the Ghana's Built Environment Regulatory Framework, these are the rules, these are the laws and regulations that actually guide the architect's work, right from the Constitution. In fact, the Constitution, if you look at Article 13, is talking about the right to life. Okay, and this borders to everyone, the right to life. And that is why somebody can take you to court if you design a building for which he considers a poor quality. He can use this article, the Constitution, to sue you and then get damages in that aspect. And if you look at the primary legislation, we are governed by the National Liberation Council Decree 357, which established the Architects Registration Council, and for which we derive our powers and our responsibility from, for which we also have the secondary legislation, that's the National Building Regulations, that's Legislation Instrument 1630, and we also have the technical standards, that's the Ghana Building Code, which was actually came into force in 2018. So it is now a law that if you go against the standards within the Ghana Building Code, you are also at fault, and for which then the professional will be taken on. And we also have our conditions of engagement, that's the Ghana Institute of Architects, for which also guides and then regulates the work and the practice that we do. Before we come to the MMDAs, that also looks at building control and then building permitting processes. So these are the regulatory framework that guides the architect's work. Now, when you look at the client-architect relationship, there are 5 variables. Now, the first one is power and autonomy, for which what is it that is about when the client's financial leverage frequently overrides professional judgment. Because the client holds the power, he has the autonomy, he has the cash. Now he determines and directs as to what exactly has to happen on site or even within the design process. Again, we are talking about trust and communication. There are times that you often have this question and friction that comes about when it comes to trust and communication. How does the client trust the architect? And what about communication levels? Vis-a-vis, the client communicating with the architect communicating with the client. And that is why sometimes the client bypasses the architect and will be talking to people on site, be it the workmen on site, relegating the architect to the background because he feels that the services is not needed anymore. And then it comes to the brief. Now, this is something that is very critical and is very crucial. If the architect does not educate the client about having a comprehensive brief, definitely is going to affect the quality of the product. And so this is where knowledge comes into play. When I was talking about information asymmetry, this is where knowledge comes into play as to how best you can understand the client so that you can advise him as to the product that he is looking for or the investment that he's embarking on. And then the almighty fee structure and then services. Although the architect is guided by the conditions of engagement when it comes to our fee engagement, there is always that power play, okay, connected to that. So yes, the condition of engagement says that you should charge 4% for pre-contract stages, but then when the client tells you that I cannot afford, then what will be the dynamics? If you are the architect who is really in need of money, then what happens? So this is what also affects the relationship. And sometimes based on this, there's disagreement, and then the agreement is truncated, and therefore you have the consequences involved. And then if we look at engagement, in terms of informal engagement, this is what is prevalent within our sector, whereby most architects or most professionals, when they are dealing one-on-one with clients, will have the verbal or the informal agreement, sometimes just about 2 or 3 words that they quote, and then that becomes their agreement. But then it is the agreement that spells out the rights and responsibilities of the client and then the architect. But this is often than not there. Now, when you look at the building quality in Ghana, literature has said that these are the contributing factors in terms of its severity. That an inadequate supervision or the absentee architect is the major cause when it comes to building quality. Of course, you have others that are higher, above the 60, which is substandard materials, client interference in the construction, and then incomplete contract documents. And you also have equally profound factors such as the engagement of incompetent contractors and then ineffective architectural design in that aspect. And so you will see that literature says 26 to 60%, okay, of all buildings that has been surveyed through literature have a minimum, below minimum concrete strength that is required according to the building code. So you see that all buildings that you find in literature for which they have reported will state that 26 to 60% of them falls below what the building code or the standards say when it comes to building construction. And so there's an enforcement vacuum, which says in the absence of effective state enforcement and the Ghana Building Code, the architect post-contract supervision becomes a primary quality assurance mechanism. So in spite of all the failures that we expect our regulatory authorities to have, if that is not there, then the architect becomes the sole mechanism, quality assurance mechanism for which the client is assured of quality service. Now, when you look at the research gap in terms of the literature that we scouted, you will see that these are the gaps that you find in all the publications, and for which this study seeks to look at all the variables, not only 2, not only 3, not only 4. So if you look at what has been ticked, these are the focus of the publications or the literature for which they focused on. And for me, that's this study. It's focusing on all the 6 which deals with building quality across up to the client relationship as the primary variable. Now, for the work itself, this becomes the theoretical framework that's building on these 3 theories. That is the principal agent theory, the professional service quality, and then the transaction cost economics, which has got to do the client-architect relationship, the post-contract service delivery, and then the building quality services. And this enforcement actually also hinges on the quality, informal procurement norms, client constraints, and then cultural attitudes to professional activity. These are all part of the effect that actually either affected negatively or positively. And so key findings in literature. The first one is that we have a post-contract service, which is a critical gap. Okay. So although the Ghana Institute of Architects conditions of engagement assign supervision responsibilities across the 6 work stages, post-contract, which is about 35% of fees for which the client has to pay and for which services are critical when it comes to quality service, is often maligned and relegated to the background. Again, if you look at all the regulatory framework and the policies that we have, there is one shared weakness, that they have maligned the service of the architect when it comes to post-contract services, and that actually also affects quality service. And then the architect supervision role, which has become now the safety net, and for which literature says that the architect, when he is engaged, post-contract services actually ensures that there's quality service for the client. And then the gap that has been identified is what we seek to fill as a contribution to knowledge. I will touch on the methodology just a bit because it is ongoing. Now, for us, we're saying that when it comes to, for what we know, we say ontology, which is a reality, and the reality exists. For my position, it's like I'm a critical realist, which is looking at a socially constructed reality, and for which produces real material in terms of the relationship targets between the client and then the architect. In terms of what we know and how we know, which is epistemology, okay, I'm looking at interpretivism and then positivism, which also looks at relational depth and then statistical patterns. And this is bordered on the mixed method that we are using for this work. Again, as an axiology, in terms of my stand, it's reflexive because I am an architect. And so I may be biased in the work. And so at every stage, you pause to reflect on your stand and how it is affecting the work. And so that is my position when it comes to axiology, which is a reflexive position. And then the methodology is a sequential exploratory, which is a mixed method, where there's no single method that captures what the research seeks to do in terms of the three objectives. And so I'm using qualitative, which is a dominant method, for which I'm using the semi-structured architect surveys with a purposive sampling. I'm expecting a number that is above 60, and for which literature has proved and backed on it, looking at the GIA membership as a whole. And then quantitative support, where I have structured questionnaire for both clients and contractors, and also literature supports that if you get a number sampling size, 80 up to 120 is enough to do your cross regression analysis, and etc. And then the third one is to where then it's integration and then synthesis, which have the joint display matrix, and then triangulation along the three groups, which will converge, seek at where there's convergence and where there's divergence. Okay. So in the architect survey, with the semi-structured questions, is clustered in 7 sessions. I'm using the Likert scale, the multiple answers, and then frequency and ranking will be used, and then open narrative for the open questions, so that I can have the thematic analysis with reflexivity. And then for client building owner questionnaire, I'm also looking at the structured questionnaire, using also the Likert scale, and then attribution ranking, and then using descriptive and inferential statistics to do that. And then for the contractor project manager questionnaire, it also seeks the same similar narrative for the building owner questionnaire, where you have the site authority items and then the quality attribution. Here, using the Kruskal-Wallis and then t-test and then regression analysis. So this is where we are at the study. Data collection is ongoing. We believe that within the next 2 weeks, it will be done, for which then analysis will continue. These are some of the key references for which guided the work. Thank you.
Thank you very much, Dr. Joe Dankwa. Please, it's time. Thank you very much, Dr. Joe Dankwa. Next on the stage for our presentation is also a materials engineer. He is a senior research scientist. He is from KNUST for his BSc Materials Engineering and KNUST for his MSc Materials Engineering, and then a PhD from Coventry University in the UK. He is in the person of Engineer Dr. Kwabena Boade. Shall we give him a round of applause?
Thank you, Mr. Chairman. Good morning to everyone. I think time is fast spent, so I'm going to be a bit snappy so that we can all get out of here. All right, so this morning I'm talking about a subject I have entitled Engineering Durable and Sustainable Geopolymer Mortar Using Calcined Clay. All right, so this is going to be the outline. I'll first of all define some keywords so that we can all be on the same page. Now, I'll bring to you a brief background of the study, then some objective scope of research, materials and methods, some results and discussion, then conclusion and take home. All right. So the first term I want us to familiarize ourselves with is geopolymer. What is geopolymer? You find geopolymer in the topic. Geopolymer is an inorganic polymer formed by alkali activation of aluminosilicate materials. Now, aluminosilicate materials are just materials that contain aluminium and silicon. All right. And so then I want us to look at what alkali activation is. And this is a chemical process where aluminosilicate, which we've already explained, aluminosilicate precursors react with alkali solutions, example sodium hydroxide, to form stable binder-like geopolymer networks. Let me take this moment to explain what precursors are. So precursors are basically the starting material of a thing, which will eventually end up in some other thing. For instance, let's use something like if you are preparing banku, your corn dough and your cassava dough is going to be a precursor. Then the banku becomes your finished product. And so the chemical activations that you are applying chemicals to some precursors to form a particular product. All right. And one thing I also want us to look at is metakaolin, because to be running through this presentation. Now, metakaolin, see it as just another version of pozzolana that we have here, but the metakaolin is a higher grade of pozzolana, if you like, a higher grade because it contains maybe better chemical composition and mineralogical composition than the pozzolana that we have here. So that's metakaolin. Then, of course, calcined clay is just like another name for our clay pozzolana that we have here. All right. Now we'll be also talking about durability. So durability is essentially the ability of a structure or material to resist weathering action or resist harsh environmental conditions. So we say that material or that structure is durable. Then lastly, we'll be looking at shrinkage. I think shrinkage is an English word, so should be easy. The reduction in volume due to moisture loss or reactions. Right, so this is the background. You realize that lately we've been talking so much about sustainability. Now, wherever you go now, everything has got to do with sustainability. And so when you talk about sustainability, you may know that the cement industry happens to be one of the leading contributors of greenhouse gases to the environment. As a matter of fact, with every ton of cement that is produced, about 0.8 tons of carbon dioxide is emitted into the atmosphere. And so if you work out the math, you realize that, and I think globally, the annual production of cement is about 4 billion tons every year. You can imagine the amount of carbon dioxide being emitted by the construction in the cement production industry only. And so because of that, over the past decades, there have been a lot of research into supplementary cementitious materials, i.e. clay pozzolana we have here, fly ash elsewhere, silica fume and all those supplementary cementitious material that we normally use to replace, partially replace cement in concrete. But then, and in the recent years, just about 10 years ago, the research has been moving from putting in supplementary cementitious materials to cut the amount of cement to totally avoiding the use of cement. And now we are looking at what we call geopolymers, or in geopolymer cement, geopolymer concrete, geopolymer mortar. Okay, so the main precursor, as I explained, that has been used to manufacture geopolymer concrete or mortar has been what we call the metakaolin, that upgraded version of clay pozzolana that we have here. All right. So what has been the problem? Even though the metakaolin is performing very well, the problem is that it has been found that it is not durable. Durability is low, even though you are getting the strength and all other parameters are working for you very well. it happens not to be durable. And so this work is looking at using an alternative material to see if it will impact the durability of this geopolymer concrete. And so for this work, we are trying to replace the metakaolin with the calcined clay as we have here to see how it fares in terms of geopolymer concrete. All right, so let me just take this moment to explain the whole process of geopolymer concrete. Now, it's amazing because we know that when you are preparing concrete, you need one of the important or the most important component is the cement. And so it is unthinkable to say that you can actually produce concrete without having to put in the cement component. All right. And so this is how it works. That it goes through that this is a lot of chemistry, so I'll just summarize it. I will leave this chemistry aspect to Dr. Csir-Brri if he comes here next time. All right. So geopolymerization process goes through just 3 stages. That's the dissolution of the precursor in the alkaline solution. For example, your aluminum and silicon is dissolved in the solution. But once it is dissolved, there's rearrangement of the silicon and aluminum to form a gel. And the gel goes through the process of geopolymerization to form a very strong 3D network. That is where the strength of the concrete, if you like, is being generated through this 3D network of the elements. All right. Okay, so the research objective is to, first of all, to evaluate the potential of calcined clay as we have it here in BRI as an alternative precursor to metakaolin in geopolymer mortar production. And also to characterize the 2 precursors, that's the calcined clay and the metakaolin through SRF. The SRF is a way of looking at the chemical composition of the material. Then SRD, that's S-ray diffraction, and that also takes a look at the mineralogical phases of the material. And strength activity index, basically talking about strength. And all these things have a role to play in achieving the kind of results we are looking for. And also laser granulometry. This is used to look at how the granules are compacted in the material. Okay. Also to to assess mechanical strength and linear shrinkage of geopolymer mortar under thermal curing. So we are going to a bit of durability to see how the material fares in terms of shrinkage, whether it expands or it shrinks when you subject it to some environment. And also to look at the durability through wet drying cycles and chloride attack and freeze and thaw cycles over a period of 90 days. Now, the wet drying cycle is that after preparing your material, one of the indicators of durability is that you have to subject it to an alkaline environment, an acidic environment, or a saline environment, okay, just like around the coastal areas. So what you do is you subject it into the environment for a period, you take it out for a period of about 90 days to see how the material reacts. And the freeze and thaw cycles, there is an equipment environmental chamber where you put in. So this is basically, this freeze and thaw cycle is, it mimics the situation of winter and summer and that kind of thing. So you expose it to summer conditions, you expose it to winter conditions to see how the material will survive in such environment. So in effect, this is the durability we are looking at. Then the last objective is to identify mechanisms governing the durability behavior of calcined clay versus metakaolin geopolymer cement. Okay, so this is going to be the scope of the research. The precursors that are going to be used are metakaolin and calcined clay. So the calcined clay was calcined, or the clay was calcined at a temperature of 1,000 degrees Celsius. The activators or the alkaline that was used was sodium hydroxide, and usually you have to prepare 24 hours prior the mixing. Then the mixed design is that we're going to use, or we used one part of the precursor, i.e. the calcined clay, to one part of the sand, that's the fine aggregate. And it was compacted under a load of 30 megapascal to make sure that it is, you give the two materials the same playing field, so that every one of them, you'll be able to determine their porosity. Because if you don't compact them using the same mechanism, one may be more porous than the other. But if you subject it to the same treatment, after that, whatever results you get, you know that you gave everybody a fair playing field. Okay, so we have different types of curing but for this work, it was cured under a temperature of 60 degrees Celsius for 7 days, 14 days, 28 days. But for the purposes of this discussion, we're just going to look at the 28 days results. Then the saline cycle I talked about, 90 days in sodium chloride solution. Then for that period, then the freeze and thaw cycle, the same 90 days. So these are the materials that we use. So this is the calcined clay. There's the metakaolin. This standard sand. Then this is sodium hydroxide, 3 moles sodium hydroxide. Then, so this is a chemical composition from the SRF. You realize the most important thing you want to look at here is the silica and alumina ratio. You realize that they are similar to each other, because the most important things you are looking at for is the silicon and the aluminum. So the ratio here are a bit similar, and so you realize that they have a fair playing field at this stage. All right, so these are the methods that were used. I'll quickly run through them. That's the clay preparation, characterization, specimen production, curing, durability cycles, and the proper testing. Okay, so these are just photos of some of the equipment that were used. We have, this is the kiln that is used for the calcination of the calcined clay. This is a strength testing machine. This is an SRD machine to look at the phases. This is the environmental chamber I mentioned earlier on, which is used for the freezing and the thawing cycle. All right. So straight to the results. This results actually is talking about the packing factor, or the packing density. So we have that of metakaolin here and that of calcined clay here. Straight away, you realize that the calcined clay has a better packing density than the metakaolin, because it has some thread-like materials in between the round or the circular particles, which makes it more compact and makes it less porous as compared to the metakaolin here. All right, so this is the strength results of the two materials. Now remember, we are trying to replace metakaolin with calcined clay. So the emphasis here is on the calcined clay. So this is the strength. You realize that the strength of the metakaolin is obviously higher than the calcined clay. From the introduction, I mentioned that the metakaolin, see it as a better version of calcined clay because of the peculiar minerals it contains. So it's not surprising that the strength is far better. I realize that the strength for the metakaolin is 88.7%, whereas that of the calcined clay is around 66.4%. And according to this strength activity index, it means that even the calcined clay at the strength level is not performing very well. It's trailing the mark, which is 75%. So the calcined clay at this point is not performing very well compared to the metakaolin. All right, so this looks at the phases present in the two materials. We have the metakaolin here, and we have the calcined clay here. And the main difference between these two are the presence of the mullite phase in the calcined clay, because all of them have the presence of kaolin, the K representing kaolin. That's the main phase you'll be interested in when you are dealing with calcined clays. But you realize that the mullite in this calcined clay becomes the main difference between that of the metakaolin and the calcined clay. As we go on, I will explain why it is so. All right. So these are results for the wet and dry cycle, i.e. soaking the material after they've been formed into the sodium chloride environment for a period of 90 days. You realize that this is the initial results, assuming it is 100, the initial result for the metakaolin, because we are comparing the calcined clay with the metakaolin. So the metakaolin, if it is 100, the calcined clay initially is performing around 72%. But after the 90-day period, you realize that the difference between the metakaolin and the calcined clay is not that much. But if you even do the calculation, you realize that after the period, the metakaolin is losing strength of 38% after it has been subjected to that sodium chloride environment. It has lost a strength, about 38% of its strength. However, the calcined clay, even though the strength was low, is more stable and lost only 19.4% of its strength. And so this is the freeze and thaw, as I explained. Think of it as within winter and within summer, how the material will fare. But let's consider just the 28 days. You realize that similarly, more severe degradation comes across board. All of them are suffering degradation. However, the metakaolin is losing about 25% strength after the freeze and thaw cycle, and the calcined clay is losing just about 15% of its strength after the freeze and thaw cycle. And this is the linear shrinkage. So we are looking at just three parameters: the sodium chloride environment, the freeze and thaw, and the shrinkage. And so similarly, the calcined clay is performing better in terms of shrinkage than the metakaolin. The metakaolin is performed between 0.95% to 1.85%, whereas the calcined clay is performed 0.55 to 1.2%. Now, calcined clay, despite lower activity index, performs better than the metakaolin. No, calcined clay performs lower, than the metakaolin in terms of the strength. But however, the mullite-rich crystalline structure of the calcined clay reduces shrinkage, a key advantage over metakaolin in durability critical applications. Then again, under the wetting and the drying saline cycle in the sodium chloride environment and the freeze and thaw cycles, the calcined clay geopolymers exhibited lower but more stable mechanical performance. And I've explained that that's because of the presence of the mullite phase that gave it more stability over the metakaolin. Now, metakaolin's high reactivity confers greater initial strength, but also greater susceptibility to volumetric degradation under cyclic stresses. And lastly, by pressing the material under the 30 megapascal load, was able to effectively control porosity in both of the materials, which allowed durability to be focused on both materials without any one of them suffering any losses. All right, so this is the take-home message. Now, calcined clay can replace metakaolin as a geopolymer precursor, but the disadvantage is that it has lower strength as compared to that of the metakaolin, which has superior strength, but rather it also has better dimensional stability and durability, making it ideal for aggressive environment. So the future studies, I believe, should focus on long-term durability. It's just a period of 90 days, and so future studies should look at maybe a period of 1 year and beyond to see how it fares. And then again, future studies should also look at its reaction when it comes to concrete. This was just on mortar, but its reaction when it comes to concrete. Then durability testing is essential for real-world deployment of geopolymers. Then again, one take-home I want to leave with you is that calcined clay geopolymers are suitable for coastal and freeze-thaw environments due to lower shrinkage. And lastly, use of industrial clay waste in geopolymers supports circular economy principles. Thank you very much.
Oh, let's give it up. Let's give it up for, you know, when the